Right, question 51. Question 51 is asking us to calculate the coefficient of variation. And the coefficient of variation is really asking or telling us, the meaning of it is telling us, is wondering, is asking what percentage of the mean is the standard deviation, if you like. So how far, how truly far, as a percentage of the mean, how truly far is this average deviation from the mean, if you like. So it's like anything. If this is a price, and you have these variations, you want to know to what extent are these other people's views from your view, if you like, if you can do that. And so for project A, the CV will be, the coefficient of variation will be 3.8 over 9.6 versus a standard deviation of 2.1 over 8.3 for B. This is for B and this is for A. And so when we do that, 3.8 divided by 9.6. So here you have a 39% situation with A, and for B you have a 2.1 divided by 8.3, and you have a 25.3% situation with B. So what you have is that B has a lower um, risk with 25.3. That's what you have here. There's a bit more variation with A. That's what you're having here. So B is much closer to the mean in terms of the standard deviation. So the answer here is D. Right. So with question 52, it's asking us. It wants to. In fact, I've got a picture up here. It's asking. You have these charts where you can see average output. You have a lower control and upper control in terms of monitoring these costs. And it's asking, what do we call this chart? Where you produce a chart that records the weight. The chart records the weights of the tins using acceptable, warning, and action levels to identify variances. So this kind of quality control process is referred to as a control chart. It's a control chart, right? So we can set targets, if you like, and have warning targets. So like anything, like inventory, weight, and if it goes above that, then we start getting worried. Let's look at 53. Company has a special order. You need 30 liters of paint. Yes. You continue. There are currently 8 liters of paint in inventory. This is totally irrelevant because it's a sunk cost. It says the company has no other use for the paint, which means that the value of that paint is now what we can sell it for. Is the initial value. So all you need to do is you have that, and you need to go out there and buy another 22 liters. So you need to buy those 22 liters at £7.60. You can't use this for anything else, so you might as well sell them. So that's the value. So you have £22. 22 times 7, 22 times £7.60, which is £167.20. And then you also have the £8 times the £1.80, which is £14.40. So when you now add these two together, £14.40 plus 167.2, you have £181.60. So this is the relevant cost of buying this stock. So we see this scenario here again. We did something like this. We are interested in the variable costs and any unique fixed costs, overhead costs. Doesn't really matter that. And what we do is, well, let's find what that is. We ignore this. We ignore the non-divisible because they are not directly in the product. Purely interested in the variable and really specific fix. So 32,000 plus 39,000 plus 6,000 is 32,000 plus 39,000 plus 6,000 is equal to 77,000. And divide this by the 1,100 gives you £70. So we know that if we make it in-house, it's costing us 70. And if we do the same thing here, we have 38, 9. So let's add those together. 38, 45, and 9,000, and that's 92,000. and divide that by the 2,300 units, divide that by the 2,300 units, and that's £40 a unit. So therefore, the question says that um, should we buy this from outside? Well, in the case of L, yes, it's cheaper, purely financial. So buy, it's either A or B, buy it. But when we look at M, it's cheaper to make it indoors. So buy out L, and sorry, buy L and make M. So A is your go-to here. And here's 55. Again, think about what we did. We did an earlier one, but it's good revision. We're told the mean. Here are the different weights. And we do exactly what we did last time. We have x mean, we have x minus x mean, and then we have x minus x mean squared. So what we have here is we have 20, 20, 20, 20, 20. 1, 2, 3, 4, 5, 6. We have 6 items. So the first one, it doesn't really matter what you do. 20.1. 20.3, 19.8, 19.9, 19.7, 20.2. I'll just change my color just because. So x minus 0.1, 0.3, 0.2, 0.1, 0.3, 0.2. I mean, of course, you're having minuses with these ones, but it doesn't matter because you're going to square all that, and that disappears. So 0.1 squared is 0.01, 0.09, 0.04, 0.01, 0.09, 0.04. Add all these together, 0.01 plus 0.09 plus 0.04 plus 0.01 plus 0.09 plus 0.04. That's 0.28. Right? And that's your total. So your total here is 0.28. Divide that, of course, by the number of units minus 1, and that's 5. And then let's find the square root. So 0.28 divided by 5 is equal to 0.056. Find the square root of that, and that takes you to 0.2366, taking you, and that looks a lot like A, doesn't it? Cool, great stuff. And that's question 51 to 55.